Good afternoon. Thanks for staying so late for this talk. I'm glad to be here. I'm here to talk about the rolling the root zone DNSSEC key signing key. The motivation for this talk is that ICANN is about to embark on a project to change a configuration parameter in DNSSEC. For operators out there, this may or may not be something that is going to affect what you have to do in operations. What I intend to do here is to inform you of what's going on, give you an idea of what's happening, when it's going to happen, why it matters. And in particular, we're highlighting that we have some documented plans available on the web for you to consult. So to give a background, I was told this is more of a general audience than a DNS crowd. I'll do a little bit of background of what this matters and why this matters and where this fits in the scheme of things. DNS, for those who don't like protocols, you ask a question and an answer comes back. And for DNSSEC, a digital signature is added to that response. And the idea is that this digital signature now can let the receiver do some verification or some validation of what they received. What is DNSSEC validation? It's taking this digital signature, looking at what's in the signature, deciding whether that signature is valid, invalid, or so on, and from that being able to conclude whether the data you've received is genuinely what you're supposed to have been receiving. Now, the validation process, we talk a lot about the cryptography part of this. The digital signature is it's a cryptographic piece of data that gets checked by a key, and that's a very big part of this work. But keep in mind there are other factors in here. Is the answer related to your question as part of this? Is the answer fresh? Has it been replayed from the past, or is it new, is in there? I'm going to stick to just the cryptography side of this because we're talking about the key management that's going on. So before I go further, too, one of the obvious questions is, why should I bother with this validation? Why is DNSSEC verification or validation something that is interesting? The DNS protocol is easily fooled. It's constantly asking questions, getting back answers, and if it's not careful, it can be very gullible and pick up bad data, be redirected to places all over, give you the wrong responses for addresses for machines and so on. So validation is basically a form of self-protection. Anyone running a DNS server out there, or a caching server, the servers that ask questions, if you want to make sure that what you're caching, what you're answering your clients with is right, you really want to go out and do this form of self-protection. There are other ways we can use DNSSEC into the future, which I won't spend much time on, but I have listed there. Now, before I go through much of this talk, I kind of have to step into a puddle of detail. Within DNSSEC, we have roles of keys. And we have different records that are involved here, and I need to explain a little bit about this for the talk to make a little bit of sense. We have a key signing key. That's a special key that only signs other keys. It just does, don't ask why. There's a ZSK, which is a zone signing key, which signs all the zone data, all the data in DNS that's not keys. These are conventions for operating this. And then we have a third thing. It's actually a record, not a key so much. It's called a DS, and it's a pointer to a key that lets us link up the security throughout the tree. Now, this setup was supposed to make operations simple, and it doesn't hurt operations, but it makes it really hard to explain everything. So going back to the boxes here, when you want to crypto check the signature, you take the data, which is the blue on top, you take a digital signature, which is in the middle, which has information about who signed this and when they signed it and what the checksum should be, basically. And you combine it with this key on the bottom, a ZSK, a zone signing key is what's going to be at the bottom of this picture. And the output of that operation is either thumbs up or thumbs down. There's no almost, maybe. It's either yes or no, because cryptography is an exact hit or not. Now, this key at the bottom, the ZSK at the bottom of this chart, is what we're starting to link into through the topic here. It's actually backed up by a chain of other keys. And then I show on the top down the root KSK with a black arrow down to the root ZSK to the column DS, the column KSK, and so on. This is a chain of keys that gets involved in DNSSEC. And we talk about DNSSEC validation. You get the data, you get the key, you validate those three boxes work together, but you have to make sure the key is reliable, and that's why you're chaining back up to some point you can place some kind of trust in. Now, the reason why this is a little hard to explain in a few slides is that in reality, that simple chain downward is just one way down to the data that was involved in this example. In the reality today, the root zone KSK signs the root zone ZSK, which then signs about 1,300 to 1,400 DS records pointing to all the TLDs, all the top-level names out there. That's right away a fan out of 1,300. .com itself also has 500 DS records within it, so it goes out even further. And .com isn't representative, it's just the biggest one out there, of course, and 500K is way more than any other of the TLDs out there. So getting back to the topic of this talks about the root zone DNSSEC KSK rollover. This is the root zone KSK pictorially. It's at the top of these chains. It's a thing that sits on top of all the DNSSEC operations that are done in normal use. There are exceptions, but this is the normal use. So this top key means something special. From the operator end of this, from the receiver, the one running the DNS server, we talk about trust anchors. A trust anchor is the top of the process. It's what an operator pulls full faith and trust in. This key is a special key. This key is going to be a key that you trust. It's like the certificates in the web browser that then sign other certificates in web pages. This is a key that you have to have trust in. Now, the trust might be implicit. It might be that you just download Bind or you download Unbound and you roll it out there, Power DNS, whatever, and they have some copy of this key sitting somewhere and you just trust it because that code was also trusted. Or you could be much more likely to do an explicit check of this by taking these keys, comparing them on your desk, doing other cryptographic checks that are available out there. However it is, it's up to you to decide how you trust something. This trust anchor is a thing that you're hinging all of your decisions on if you're running DNSSEC validation. The first question here is the root zone KSK, the key that I'm talking about, the trust anchor? And the answer is it depends. It's up to you. The trust anchor is something you choose locally to run your recursive servers for validation and so on. It's up to you to decide whether you trust that. By convention, the root zone KSK covers just about anything that's operationally hooked together right now in DNSSEC. There are holes in the tree right now where things aren't signed properly. You can add other trust anchors in your code if you feel like managing it that way. But if you're doing it at scale, you probably aren't going to have too many of these turnkey or extra keys installed. But tools can allow you to use that. So, and also to give you some more background of how the DNSSEC has operated the root zone, it's done in a special way, of course. There are two bodies involved right now. There's ICANN. We run the IANA functions, and part of that is to run the root zone KSK. VeriSign is the root zone maintainer. They've been producing the root zone for years. They've been sending it out to the root server operators. As part of that function, they operate the root zone ZSK, the zone signing key. And that's why I bothered to explain the two differences. The KSK means we take care of the KSK. We created it once. We're going to roll it. We're going to manage the security of it, publish it, and we use it to sign the ZSK once a quarter, so 4 times a year. Operating the ZSK, VeriSign does this work. They manage this life cycle of it, and they also sign the root zone with it every time they send out a new copy of the root zone. Our two organizations do these functions separately, but we're also very coordinated. We talk all the time, but we're doing separate jobs. And this helps make sure that we're securing the root zone, the DNSSEC, properly. Now, the current root zone KSK was created in 2010 and put into operation back then. It has not been changed since then. We keep it secure in security HSMs in 2 locations, in the East Coast and West Coast of the United States. It's tempting to go into the background there. I have a whole 45-minute talk about that, but now's not the time for that. But we have a lot of information about how we run this, and we're very happy to go with it. If you really want to see how we do the operations, we will talk about that. We try to expose as much as we can. For those of you who want to get a copy of the root zone KSK, there are a couple of ways of getting the key. The key is in the DNS, and you can actually grab it from the DNS. If you do that, beware that if your DNS is being attacked at the moment, you may not be able to trust the key that way. It's kind of hard to convey to you a key securely in the system I'm trying to secure with the key, but you can get it that way. You at least get the data right. We also publish it on a website. We have I have a file there, an XML file, which has the trust anchors inside of there. And there's some more security behind that. You can, again, verify this. There are other means out there. Software distributors have the key in there. There have been presentations we talk about. I've mentioned the key in places. There have been T-shirts printed with this and so on. You can also check other operators to make sure you have the same kind of key. It's one thing to get the key syntax correct. It's another thing to begin to trust it. And you may have levels of trust that you want to meet. Trust on first sight, trust on first use, or you may want to do some more due diligence. It's all up to you to do that. It's whatever fits your needs. So changing the root KSK, we have a plan in place to change the key. And in fact, the plans have been out there, and in 8 days we start the process by creating the new key. And that's going to be the first thing we do, but it won't be visible to the public. So you can look at the plans and have some chance to look at this still. Still got quite some time to prepare for this, though. What's really precedent-setting about this project is that on one end, ICANN is going to do something. We're going to do a few commands. We're going to create a new key, and we're going to be ready to sign with it. The problem is that everyone else out there who wants to set up a trust anchor based on the key has to get it and then also configure it. We don't know who that is. There's no roster of who needs to get this key. We have to talk to everybody to make sure, if you need to know about it, here it is. That's the best we can do, and that's why we're going around and making sure you know about this project. There were no analogies I could find in any other projects that hit the scale of it's me and everyone else, or no one else. I don't know. Anything could go out here. So now the one thing we keep in mind is that there really isn't a need to change the key right now because we have a problem. There's no emergency going on. The key is not wearing down. It's not losing bits over time. It's not losing air or whatever. But the change is being done, first of all, because cryptographic assets don't live forever. At some point, they will become not working, basically, not secret. And secondly, though, it's for operational hygiene. We want to make sure that we can change the key in normal situations without an emergency, with level heads and planning, before we try to have to do this in an emergency. We don't want to have the boat sinking when we have to start figuring out how to use the life preservers. So we're going through this process of doing this just to make sure we can do it. It's an operational best practice. And why not do this privately? Why not testbed this? Because part of what we're learning is it's the elements outside of our control, outside of our operations area that need to be updated. We're making better contacts with software developers, with the distribution chain of DNS out there, with operators. We're trying to make sure that we know who needs to know. We're getting a better idea of who needs to know this and how and why and when. Now, so the bottom line is for all the root KSK change will impact just about all DNSSEC validations. If someone out there is validating today and they don't update their trust anchor in time, the entire internet will go off for them. They'll get serve fail for everything. Not just things that are signed, everything, because you can't prove anything. If you expect security to be there and you get no security data, DNSSEC is going to say something's going on. It drops everything. Now, so at this time, trust anchor maintenance is going to be something that we want to start building some awareness of, and it's a good time to start thinking about how do we trust any of the cryptographic assets we have in our operations. It's a good time to look at that. So the project is meaningful if you're doing DNSSEC validation. Jeff Houston's measurements indicated about 15% of resolvers out there are actually doing some DNSSEC, so it's not zero, it's not a lot, somewhere in between. People need to hear this. The whole process of signing is not affected. This is all about validation, running recursive servers, serving users out there. And if you're validating, it's a time to begin to think about preparing for this rollout there. And we, frankly, still have quite a bit of time, but this is maybe the first warning I want to get out there. This is the first time we've rolled the root KSK. It's kind of unprecedented, so we all have to be kind of on the ball for this. We have some documents out there that if I want to make you aware of. The documents are listed here. They're available at that URL on top up there. We encourage you to read these. We're not looking for formal feedback. We don't have a formal feedback mechanism, but if you see something wrong in them, please let us know. We're not perfect, but we've gone through a long process to get to here. We'll listen to it, but we're not setting aside a special time to get more feedback on this. According to the plans, the big highlight is on October 11th in 2017, which is about 51 weeks from now. We plan to start using the new key and getting rid of the old key in operations. So we have 51 weeks to get ready for this event right now. There are other significant events along the way that I'll talk a little bit about, but In the plans we're using, for those of you who are curious, we're going to use the same kind of key we're using now. We're not changing the cryptographic algorithms out there. The libraries and all that will be the same. We're following something called the automated updates of DNSSEC trust anchors. It's an RFC 5011 if you know those numbers. That's a way in which we publicize the key. You can look at the key and decide whether you want to use it or not. This is taking quite a while because we're not in a rush. There isn't an emergency. We don't have to, so we're doing this at a slower pace. And we're fitting it into existing events that we have right now. So there's no extra cost in operations to doing this the way we're doing this right now. We're also beefing up testing and monitoring of the systems involved to see if we can detect stress on the system, so we can also help operators prepare for what's coming up. In doing this work, we had a few concerns, and I want to let folks look at this, and you might want to consider this as things to look for. During the plan roll, the DNS responses, some of the responses that are going to matter, I'm not quantifying which ones, may grow as high as 1,425 bytes. Some experimentation with IPv6 is that might be kind of interesting on the network to see if it goes that big before fragmentation kicks in. The odd thing is, though, empirically, we know of many examples of TLDs running with very large key sets, even larger than that, and we've never had anyone cry foul or error or a problem out there. So we don't see that there's necessarily going to be a problem, but we're watching out, and that's the thing that we are trying to design around. For operators out there, anyone who's running DNS servers, things to look out for is one thing: keep TCP open for the DNS services. It's how the DNS protocol natively will fall back to TCP if it can't get it through UDP, and keep that open. And really try to restrict filtering based on DNS message size. That used to be a big problem, less so now, but just make sure that you let DNS determine what size message it has to pass back and forth. IPv6 fragmentation, why that's an issue is, in v6, the network no longer fragments. So you have to send out things according to the maximum transfer unit to begin with. If you don't, you get back an error message saying this was too big. DNS has no memory, so once it sends a message and is told that was too big, it forgot what it sent, and it's not going to do it any good. So that's why DNS is kind of feeling the pinch in this area. Jeff Houston has an article which I would love to summarize in the talk, but don't have enough time to do that. It's at the URL there. It was from May of this year. It was in his on his potteroo.net account, ISP column, I think it's called. And he talks about the MTU settings and the information behind that. There was some good information in there, and I have a but in quotes on my slide because that would have taken 3 or 4 slides to explain, and I don't have the time for that. But I would encourage you to take a look at that article if you have an interest in v6 and what's happening with this, and look at some of the MTU settings you have on the computers that you have, the servers. So dates to watch. The first date I'm actually going to mention is not on here. In 8 days, we're going to create the key. The new key will be created in 8 days from now at a key ceremony in Culpeper, West Virginia. That's not going to be a visible event, so we don't have it on the slide, but since it's 8 days away, it seems kind of interesting to talk about. On September 19th in 2017, we're going to put some of the keys into the DNS, or put the key into the DNS. Actually, it's a role, it's a long story, but we're going to put more information in the DNS on that date. And the response size will grow to 14 bytes, which is above a threshold that some of us are concerned about. We're going to watch what happens there. If nothing goes wrong, it's acceptable, we keep rolling on. For the next 20 days, we have a very large set compared to today. Today, it's about maybe 800 bytes, I think, or 1,100 bytes at the highest. It's going to go to 14 then. We have to watch out for that. Operators will probably may see that more than anything else. On October 11th, we changed the keys, and that's basically swapping the new key in for the old key coming out. And if you haven't kept up, don't have the keys configured, everything goes dark. January 11th, we go through the process of revoking the old key formally, and that's when we go to 1425 bytes. Again, another new high at this point for the potential fragmentation that exists. So those are the 3 main dates for operators looking out there. And you can see these dates are nearly a year into the future, so we have some time to prepare for this still. What do you do in the meantime? Look at how you do trusting and configuration, how you do trust and configuring trust in your DNS servers and probably other places too. How do you do configuration control? How do you manage your DNS servers out there? The reason why I mention that is The automated updates of DNSSEC trust anchors, the middle bullet there, which is RFC 5011, assumes that you let your servers self-manage. These servers will go out there and they'll do some queries and they'll see, oh, a new trust anchor, and I'll adopt that by myself. If you do centralized configuration management, you may not want to have that happen in your network. So you might want to account for that some way. You may want to have another server do that and then tell your centralized servers to push things out. There may be some preparation in pushing this out there. Because the alternate to that is you don't need to use the automated updates. You can do it all manually, push it out yourself, but then you have to be more aware of what you're trusting. Also, a newer feature of the DNS out there is called negative trust anchor management. This is now appearing in more and more of the more recent versions of software out there. It's a way of saying ignore others' trust anchors, ignore other zones' DNSSEC mistakes by putting in a don't trust this key area to help block off some of the errors. That is an outcome of one of the famous examples of NASA.gov screwing up or messing up the DS record change a couple of years ago and it impacting one of the ISPs out there. So that's finally made it into commonplace software. Tools and test beds that are out there. ICANN is working with software developers and tool developers to look at having better tooling out there for this. We've talked with a lot of the operators already or not the operators, the software developers that produce the DNS out there. We're making them aware of this. We're also making sure that they know of the new keys when the keys are available so they can put it in their software. There are test beds for code developers that exist. Now, code developers, not operators. These two URLs have sped up versions of the RFC 5011 automated updates protocol. To run them, you have to change critical parameters, and you probably don't want to do that in operations, so we don't consider that to be necessarily an operator-friendly test bed. We are constructing a test bed for operators' use. It's going to do the RFC 5011 change in a certain way so that you don't have to change any critical parameters in the code. You can try that in the background to see if your software that you have out there is actually following this and whether or not those trust anchors are actually going to be managed through your configuration management system out there. So that's the end of my slides, my informational slides. There's some contact information here. We have a mailing list for the KSK rollover that you can join and you can hear some of the announcements out there. There's a Twitter thing, and we have a web page off of the ICANN.org web page. There's a KSK role selection. You can get information about what's going on there with updates on the process of this.